Okay. So what are the considerations to be taken choosing between flip-flop versus latches in a design? So what are the consideration we'll see whether to choose flip-flop or latches in a design. We'll see this thing. So area of a latch is typically less than that of flip-flop. So they are telling that latch is having latch will take less area. Okay. Area of a flip-flop for same feature is more than that of latch. Okay, so this is they are giving a one point. Okay, the flip-flop area is more as compared to latch area. Consume lesser power due to the lesser switching activity and lesser area. So power consumption is also less due to less switching activity and lesser area. See, I don't have a valid point to justify this statement. Okay, just I'm reading. So power consumption is typically higher due to the area and free running clock. Higher due to area and free running clock. Additional controls required to save power. So if you need to save the power during that time, you can additionally control that thing with the help of getting clock getting, you can save. Facilitates time borrowing or cycle stealing, help increase pipelining depth with lesser area even if the path is longer than the clock cycle. For the latch based pipeline, it is okay as long as it meets the next latch setup margin. Okay, actually they're telling that in latches there is a concept of time borrowing and cycle stealing. Okay, by which you can increase the frequency of your circuit. Okay, we'll see that thing that will come in next slide. Okay, how we can increase. Since the clock boundaries are rigid, the facility of time borrowing or cycle stealing doesn't exist with flip-flop. So a negative slack cannot be propagated to the timing of the next stage in a pipeline, and hence must execute within a clock period. So they are telling that in flip-flop within one cycle you have to execute you have to sample the input, and you have to sample the input within one clock cycle. Okay, so in multiple clock schemes the clock edges must not be overlapping, so it makes a logic design, vector generation for verification and clock tree synthesis difficult. So they are telling that multiple clock schemes the clock edges must not overlapping, so it makes a logic design, vector generation for the verification and clock tree synthesis difficult. Actually this is some issue they are telling pertaining to backend. Okay, where they will face this problem, generation for verification and clock tree synthesis. Okay, clock tree synthesis is less tedious in flip-flop based design since the stimulus need to be stable before the setup time of the clock, and the vector generation is relatively easier. So they are telling that clock tree synthesis is less tedious in this flip-flop, because they are telling that stimulus need to be stable before the setup time of the clock, so that will come. Okay, they are telling that usually your stimulus will become stable, usually it will come before setup time itself, and the vector generation is relatively easy. So vector generation is relatively easy, means they are forcing some values, some vectors they are telling. With time borrowing and cycle stealing, the operating frequency is higher than the lowest logic path. So they are telling that the operating frequency is higher than the lowest logic path. So even your path is so actually what lowest means slowest path will only give you the frequency, right? So they are telling that operating frequency is higher than the slowest path. So even if your path is slowest, that